Alright, good morning everyone. Today we're going to be talking about the chemical composition and all of the chemical reactions that go into making firecrackers work. Firstly, we're going to list the common components in a firecracker. I have added a little diagram here so you can see how it works, and then we're going to describe each one of them. We have the outer shell, the black powder, also known as gunpowder, the fuse, and during the reaction and after the reaction, we have gas release and a flash of light. Let's start by talking about the outer shell and the black powder. So when it comes to the outer shell of a firecracker is usually made of paper or cardboard, and it serves as a container for the other components. So basically, the reaction itself happens inside of the shell. Then we have the black powder. Black powder is a primary propellant in most firecrackers, and it consists of three main components. Firstly, we have potassium nitrate, or KNO3. This is going to be the oxidizer in the mixture. And then we have charcoal, which provides fuel for the combustion. And finally, we have sulfur, which enhances the burn rate and combustion properties. The chemical equation for the combustion of black powder, simplified, is the following, in which 6 molecules of potassium nitrate react with 1 molecule of charcoal to produce 3 molecules of potassium carbonate, 4 molecules of carbon dioxide, 2 molecules of carbon monoxide, 5 molecules of water, 3 molecules of nitrogen gas, and 4 molecules of sulfur. So as you can see, this reaction generates a lot of hot gases, such as the carbon dioxide, carbon monoxide, and water vapor, as well as nitrogen gas and the potassium carbonate. But to make a firecracker work, we need something to start the combustion itself, and for that we have the fuse. The fuse is typically made of a slow burning material, such as cotton or paper soaked in a pyrotechnic composition. It provides a delay before reaching the black powder, and it allows the time for the user to light the firecracker and move to a safe distance. Without the fuse, a firecracker would just explode straight away and probably leave you with very bad burns all over your hands, so it is necessary to make a firecracker.
Here's a simplified breakdown of what happens during combustion. First, we have the ignition. The heat from the lead fuse initiates the decomposition of the black powder. Then, the oxidation. In the process, potassium nitrate in the black powder provides the necessary oxygen for combustion. It breaks down into potassium oxide and nitrogen dioxide, releasing oxygen gas in the process. The chemical reaction of this process goes as follows. Ta-da! When two molecules of potassium nitrate undergo a chemical reaction, they transform into the one molecule of potassium oxide, two molecules of nitrogen dioxide, and one molecule of oxygen gas. After we have the combustion of carbon of charcoal, during this step the carbon in the charcoal reacts with the oxygen generated from the potassium nitrate, producing carbon dioxide and carbon monoxide. But like the example, the release of water and nitrogen gases. Then there is the release of water and nitrogen gases. After that, the sulfur also contributes to the combustion, releasing sulfur dioxide and other sulfur compounds. The nitrogen in the black powder also contributes to the gases released during combustion.